In this video, I want to talk about work done by a constant force. Okay, and I also want to talk about how we can determine the kinetic energy of this object in this situation as a function of displacement. Okay, as a function of displacement. Now, by doing that, we can take our initial velocity, or our final velocity squared, is equal to our initial velocity squared plus 2 times the acceleration times the change in displacement. Okay. And now, with that being said, we know what our acceleration is in here with the negligence of friction force, or with the negligence of friction. So that's going to be our acceleration is going to be equal to the cosine of alpha times g. And alpha in this situation is going to be equal to 90 minus theta. Okay. 90 minus theta, because this is a right angle, and we can safely assume that the x component of the force of gravity, is going to be cosine of alpha times our gravity. Now we can plug in our new acceleration, what we found, into our velocity squared. Final velocity squared is equal to, and I'm also going to actually zero this out because we can safely assume that we are releasing this object from the top at initial velocity of 0. Okay, so we can say 2 times our new acceleration vector. Okay, actually it's a scalar because it's an x component. Cosine times cosine of alpha times our gravity times our change in displacement. Okay. Now, remember that our kinetic energy is equal to 1/2 times our mass times our velocity squared. Since we just found velocity squared, we can actually plug this in here. Okay, and we are going to get a function with respect to displacement of this object falling by a constant force, and we're with neglect of friction, so we can actually plug this in. The kinetic energy is equal to 1/2 1/2 times our mass times 2 times our cosine of alpha times our gravity, or our acceleration, but in this case it's a force of gravity, times our change in position. Okay, these 2's are going to end up canceling out. We're going to end up getting the kinetic energy is equal to mass times our acceleration due to gravity times our cosine of alpha times our change in displacement.